Hello again everyone, it's Nick at Final Descent UK. Welcome to our AAIB Bulletin Debrief for April. There's lots to get through this month, so I'm splitting the debrief into two videos. This part will discuss the 3 commercial incidents in Bulletin, and the second part will discuss the general aviation incidents. The first report referenced in Bulletin is the Rockwell Commander crash just before Christmas last year. I've covered this in a separate video and the link should be above and below now. The commercial incident we'll discuss first concerns an ATR 72 owned by Jump Air, which is a charter provider but this time operating as an Origny flight. This was the second leg of the day in August 2024 and the aircraft was refueled and passengers boarded for the return from Southampton to Guernsey. When the aircraft departed Guernsey, fog was already starting to develop but the visual range down the runway, the RVR, was more than 1500 metres. After looking at the weather reports, the forecasts, the commander considered it likely that the weather would improve sufficiently by the time the aircraft would arrive back on the return leg from Southampton, and the aircraft departed there at 7:15 AM. During the flight, the crew reduced the speed of the aircraft several times to delay their arrival to try and give the weather sufficient time to clear. Despite this, the crew had to enter a hold over Guernsey as the RVR was less than 550 metres, which is the minimum required for the Category 1 ILS approach to runway 27 at Guernsey. After spending around half an hour in the hold, ATC advised the crew the RVR had improved to 550 metres and the crew elected to proceed with the approach. Radar vectors were given to establish on the ILS, however during the final approach the RVR decreased to 450 metres. ATC relayed this information to the crew, who continued with the approach and were switched from the approach controller to the tower. As the aircraft passed 1700 feet, the controller informed the crew that the RVR had decreased to 325 metres at the touchdown zone, improving to 400 metres at the runway end, and as you can see from this chart, the RVR was only over the minimum for a period of 1 minute across the entire approach. ATC informed the crew of a further deterioration in visibility to 375 metres as the aircraft passed through 1500 feet. Remember that the RVR for this approach is 550 metres, but the crew continued the approach below 1000 feet. In both UK and EASA regulations, crews should not continue an approach below 1,000 feet above the aerodrome elevation if a runway visual range is below the required minimum. This is referred to as the approach ban altitude. The idea of this regulation is to prevent go-arounds from the approach minima and therefore reduce the risk of an aircraft being manoeuvred at low level in poor visibility, which would lead to an increased risk of uncontrolled ground contact. Now unfortunately, that seems to be exactly what nearly happened here. As a decision altitude of 536 feet was reached, both the commander and the co-pilot gained visual contact with land. However, there was some confusion between the crew members and the co-pilot called for a go-around. For the next 15 seconds, the aircraft did not climb and the radio altitude remained between 61 and 78 feet before finally starting to ascend after travelling over 750 metres over the ground and narrowly avoiding the DME transmitter. The aircraft then returned to Southampton where it landed without incident. This image from the report clearly shows how poor the visibility was on the day of the incident compared to the following day where no fog was present. The event was reported to the AAIB on the same day as it occurred. However, as the aircraft had continued in service, the cockpit voice recorder had been overridden. Therefore, an interview with both pilots had to be relied upon to try and piece everything together. The crew stated that during the approach briefing, neither pilot discussed the approach ban altitude, and the captain reflected that he felt he was following the old rules where it was allowed to continue down to the decision altitude no matter what the visibility was. The co-pilot stated he was aware of the approach ban regulations, but did not offer any challenge. Interestingly, in previous simulator testing, the captain had to be reminded that the ATR was a multi-pilot aircraft, perhaps reflecting an authoritarian approach, and the co-pilot in similar tests had received the suggestion that he should not hesitate to assist the pilot flying where necessary. The crew stated that on final approach, the co-pilot called for minimums on reaching the decision height, and the pilot called contact, land, as per the SOP. The autopilot was disconnected for landing. However, the co-pilot then called for a go-around, and as the SOPs require go-around to be flown should any crew member call for it, the commander called go-around, set power, flaps 1 notch, and noted the co-pilot retracted the flaps as requested. The commander then called for the gear to be retracted, but the co-pilot seemed unresponsive. The commander reported that he called an additional 3 times for the gear to be retracted, but the co-pilot either couldn't or wouldn't retract the gear. The commander eventually reached over and retracted the gear himself. The co-pilot's version of events is that he called minimums, he heard no response from the commander, so called for a go-around. The flaps were retracted, but when the commander called for gear up, the aircraft did not have a positive climb rate, so he did not retract the gear. He recalls prompting the commander to climb and pitch up, which is why he wasn't retracting the gear, but he received no response. So, he pulled the control column towards himself and remembers the commander retracting the gear. Now remember, the cockpit voice recorder had been overridden, so we'll never be sure exactly what communication occurred in the cockpit. It seems that a breakdown in communication and lack of shared mental model led to a situation where neither pilot was aware of the aircraft's low altitude, between 60 and 80 feet, for 15 seconds before a climb was commenced. In that time, the aircraft travelled 750 metres over the ground. This was probably during the period where there was confusion between the pilots as to the raising of the landing gear. The operator, Jump Air, is a Lithuanian charter carrier, and its crews come from multiple nationalities. Although both pilots spoke English, it was neither of their first languages and they spoke no other language in common. All crew are assessed to an approved level of English competence, but the challenges of good communication can be increased in stressful and unfamiliar situations. As a result of this incident, the operator has implemented a flight data monitoring program in an attempt to enable early identification of recurring issues, and revised and enhanced their recruitment process in regard to psychological assessment of their pilots. They've also changed simulator processes to include scenarios that require co-pilots to actively challenge commanders' decisions when deviations and errors occur. The second incident was an easyJet A320 Golf Echo Juliet Charlie India operating as Easy 82 Uniform Juliet on departure from Toulouse on the 30th of January 2023. The investigation was undertaken by the AAIB's French counterpart, the Bureau d'Index et d'Analyse pour la Sécurité de l'Aviation Civile, or BEA for short. Not sure if that was any better than my Polish last time. The aircraft was returning to Gatwick from Toulouse and was running an hour and a half late. The crew discussed the various takeoff points on runway 32 right at Toulouse using an application provided by the operator. The application suggested that either the full-length November 1 departure point or November 2, which would have given 2,300 metres. The crew elected to request November 2 as their departure point, presumably to save on taxi time, and carried out performance calculations using that intersection as a reference. It's relevant to note that the application used for performance calculations only shows intersections available for takeoff. Unusable intersections don't appear visible to the crew. The aircraft was cleared for push and start at 16:52 and then to taxi to the November 1 holding point for runway 32 right. As the aircraft approached the exit of the apron, the commander asked the co-pilot to request a departure from November 2. They were cleared for this by the ground controller and instructed to contact the tower when ready at November 2. Whilst taxiing, the crew performed a PEDS briefing, which stands for Performance, Engine Out Procedure, Departure Runway and Routing, and Stop Altitude and Departure Clearance. Following that, the crew informed the tower they would be fully ready on reaching November 2, to which the tower replied, Bonjour, from November 2, 2,300 metres, cleared for takeoff, 32 right, winds 310 degrees 12 knots. This was read back, and at the same time, the commander turned the aircraft right towards the holding point November 4. The crew completed the line-up flow, which required that each pilot silently verify takeoff intersection. The runway holding point November 4 was clearly signposted as per the image. The aircraft began its takeoff run, rotating with only 500 metres of runway remaining. During the climb, the crew discussed the short length of the runway remaining and realised that they'd begun their takeoff run from November 4. The distance available from November 4 was 1,800 metres. The crew informed the investigators that the operational environment they were working in at Gatwick was very demanding and significant delays occurred on most duties due to lack of ground staff. The commander stated that this had led to a desire to stay efficient and keep the operation flowing where possible. The co-pilot was new and only on his 8th sector of flying since completing training. He said that he felt the pace of operations was much quicker than he had expected after training. Neither pilot had flown together before and neither were familiar with Toulouse airport. The co-pilot reported that the short taxi and early takeoff clearance meant that he was heads down for the most of the taxi, completing various checklists and flows. He felt he was fully task saturated and couldn't recall seeing the runway signs for the November 4 holding point. The pilot reported as their pushback was an hour late. The checklists were conducted promptly but not rushed. He was aware that the co-pilot was becoming task saturated and was monitoring his actions closely, which is why he didn't notice the holding point signage for November 4. Air traffic control was also investigated. After all, they gave no warning to the aircraft that they had entered and were about to take off from the incorrect intersection. It transpired that normally there would have been 5 controllers on duty, however at the time of the incident there were only 3. But the workload was very light and there were only 2 other aircraft in addition to the easyJet A320 on the frequency. The ground controller handed the aircraft off early to the tower controller to try and be helpful as he knew the aircraft was running late. After doing so, he didn't continue to follow the aircraft visually. The controllers felt that the crew knew what they were doing and knew where they were going. The tower controller didn't confirm the position of the aircraft visually before issuing takeoff clearance, and the controllers blamed their lack of concentration on just starting the shift and a low workload. easyJet analysed the flight data and the calculated performance, which was assuming the aircraft took off from the November 4 intersection but using the November 2 intersection performance calculations. The conclusion was that if a rejected takeoff had occurred at V1, there would have been a runway overrun of 102 metres, and if an engine failure had occurred after V1, there would have been an obstacle clearance of just 45 feet. Following the incident, easyJet formed a working group to review the risk of runway incursions and related procedures, and updated their operations procedures to require all taxi intentions to be announced by the pilot flying to the pilot monitoring. Toulouse Air Traffic Control issued a safety bulletin reinforcing that controllers should be constantly monitoring manoeuvring aircraft by visual observation, and that the ground controller remains responsible for aircraft movement all the way up to the runway holding point. But nothing's mentioned about what I think is a massive contributor to the event: the time and workload pressures for easyJet pilots operating out of Gatwick. I'm not sure how much this will have changed in the last couple of years. The third and final commercial incident concerns a different easyJet A320, Golf Echo Zulu Golf Yankee, operating as EZ23 Uniform Delta, landing at Corfu on the 19th of June 2024. The Greek equivalent of the AAIB, the Hellenic State Investigations Authority, which I am absolutely not going to attempt in Greek, delegated the investigation to the AAIB. The aircraft was configured with flaps full for a night landing on runway 34 at Kakira Airport. The aircraft was stable on approach but drifted high on short final due to an early flare. The co-pilot reported that darkness and the lack of runway centerline markings made it difficult to judge the final approach. However, he had assessed that the landing would occur within the touchdown zone, so he selected reverse idle when he felt the main wheels touch down. The commander felt a little different. He recalled that the aircraft had passed the final touchdown zone marker at a late stage in the flare. easyJet's policy was that the go-around should be flown if main wheels were not on the ground before the end of the touchdown zone, so he called that he had control and selected toga thrust to initiate a balked landing go-around. He was unaware that the co-pilot had already selected reverse idle thrust and only realised that after he'd set the thrust levers to toga. The Flight Crew Techniques Manual for the A320 states that a go-around should not be initiated after the selection of the thrust reversers. The commander was aware of this, but also aware of what he had just done. He was startled and surprised, causing hesitation as to whether to continue the go-around or reject the takeoff. This was made worse when the master warning tone sounded because toga was selected whilst full flap was deployed, alerting the crew that the aircraft was not in the correct takeoff configuration. During this episode of surprise, he cycled the thrust levers to maximum reverse, then back to toga again. The commander finally selected Rev Max and applied maximum manual braking. At a similar time, the co-pilot was becoming concerned that there was insufficient runway to take off and called stop, and also applied maximum manual braking. Flight recorder data also showed that the co-pilot applied a nose down input on his side stick. However, this was cancelled out by the action of the commander, who was holding down his side stick priority button. The aircraft stopped with 340 metres of runway remaining. So why was the commander so concerned with initiating a go-around in this case? As I've mentioned, the Flight Crew Manual states that go-around should not be attempted after reverse thrust is selected. The thrust reversers on the A320 aircraft follow a complex logic to determine whether or not they're safe to deploy. In simple terms, the reversers won't deploy unless the corresponding main landing gear is compressed and therefore on the ground. This was relevant on Air Portugal flight TP754 from Lisbon to Copenhagen on the 8th of April 2022. The approach became destabilised during the flare and the aircraft bounced several times. The pilot had selected maximum reverse when the left gear came in contact with the ground. The reversers began to deploy after the right gear also made contact with the runway, but the flight crew elected to perform a go-around at that point. The left main gear was briefly uncompressed when toga thrust was selected, and the pilot flying selected flaps 2 and applied nose up inputs. Engine 2 spooled up to toga thrust, but engine 1 remained at idle and the reverser was still deployed. The crew experienced difficulties controlling the aircraft and it drifted left of the centreline, requiring nearly 60% of full rudder deflection to regain control. Luckily, the crew managed to land safely on the second attempt with the number 1 engine reverser deployed, but things could have been very different. The two engine control units had a brief delay between their respective computations of whether the aircraft was on the ground or in the air, leading to the engine 1 thrust reverser failing to stow. Airbus examined flight records from more than 3.2 million flight hours and came to the conclusion that approximately 1 go-around per month was being conducted after thrust reverse was selected, going against the standard operating procedure for landing and risking an event like this happening again. Luckily, the easyJet pilots during this incident both came to the same conclusion to keep the aircraft on the ground and not continue with the go-around. There were no specific safety recommendations made following this incident. Given the alarming frequency at which incidents similar to this may occur, a software update for the CFM56 engines has been developed and should be available later this year. Thanks again for listening to part 1 of April's debrief video. Part 2 should be with you sometime during the Easter weekend. Bye bye.